Good afternoon, everyone. This is Luther P40. Just playing around with my ZFF PWM. Just trying to get a handle on how to adjust the current limiting on it. And basically, that's what it looks like on the inside. But then again, you've probably seen that over on zero sites. Yeah, basically what I was doing with this was, I set the thing, got the thing going. I had to fix. There was a loose wire. Had to solder back over here on this negative terminal. Got that going, and I went through and readjusted it. One thing I've noticed with this is that. The current limiting works, but it's completely dependent on the input voltage. As long as the input voltage is exactly the same, the current that's allowed to pass is always going to be exactly the same. And that's what I'm looking at, anyways. Let me fire it up, and I want to show you an anomaly that I got. Let me show you the anomaly that I got, and maybe you guys can tell me what I'm looking at. Anyways, I'll be right back. All right, I'm back. I've got the thing fired up. I've got it fired up. Got it set at the 13 point. Well, it's supposed to be 13.8 volts. Coming out of the power supply. It's also wired in parallel to that, and right this minute the power supply is drawing about 24 amps, but that's because it's back charging the battery. Once the battery gets charged up, that'll go back. That'll end up matching the these two will match each other once that battery's charged back up. But one thing I noticed is it always comes up to that amperage no matter what the temperature of the cell is. You notice I got the cell right this minute. I got it configured as a 4N4. One thing, the anomaly I've noticed is that if you're in your car and so you got a poor regulator, or you got, you turn on some heavy duty accessories, your voltage is going to vary from time to time. Let me put this to volts. So I'll crank up the output volts. But if you notice, my amps are going up too. Current limiting, this is controlling the input voltage is controlling the amps. If I drop this down, I start pulling off the battery, and then it starts sagging off again. But as long as I'm at the original, if I'm at the exact same voltage, my current limiting works as expected. Now, one thing I noticed, this is the part that I'm asking you guys about, is I know this is kicking in and out, and it is cutting back, throttling back, because my voltage at the cell, which also this is the sum voltage for the entire cell, but the voltage, this also affects the voltage per plate. But if I crank up this voltage here, it barely moves. So I'm running 15 volts. I'm running 15 volts on that thing, but my voltage at the cell is, the RMS voltage at the cell is basically the same. So I'm turning it down, turning it up, but it's still at 12.2, 12.3, 12.4. So it's not, this variation is not near as great as what I'm putting down here off of the power supply. So that's an interesting anomaly, in that, to me, I'm wondering if I can actually dial this in. It seems like, yes, it's limiting current supposedly, but see, it's always coming back to that 20 amps. But it acts more like it's a voltage regulator at the cell. So I'm wondering if I can dial this in so I get my 2.2 volts per plate, even on 4N4, which I believe this would need to be dialed back to 11 volts. Dial this back to 11 volts with it using the PWM. Yeah, we'll see. And that amps will end up going back down. But what I'm wondering about is if I can get my 2.2 volts per plate or per gap by using the PWM. Well, I'm more or less right this minute I'm thinking out loud. So let me see if I can dial it in. See if I can dial it in at 11 volts and measure some voltages plate to plate. Alright, be right back. Okay, I'm back. What I ended up doing is I ended up dialing it for 2.2 volts per gap, and they ended up giving me 11.25 volts DC, and that gives me 15 amps going to the cell. And you see it's still cooking away. And I want to try the same experiment again. Just start cranking it up. So full 15 volts coming into the system. It's 11.34 volts at the cell. And I have to pull the meters off. I need a second meter. But now I'm pulling 17 amps as opposed to the 15 I was a minute ago. So yeah, I'm not trying to slam this PWM. I actually, if this is what I think it is, what I'm looking at, if this is what I think it is, you could pretty much, I mean, I'll have to experiment some more. I'll try a 3N5 arrangement probably next. 3N5 arrangement and see if I can do the same thing. I don't know if I can dial it down that far, but I think what that might mean, is it might be possible that it don't really matter what your plate configuration is, as long as you dial in the PWM so that your RMS voltage or your gap voltage, RMS gap voltage, is still the 2.2 volts. And that'd be so slick right there, because I can make all these plates hot. I don't know if I can go that far. I don't know. You know, this is outside the scope of what it was originally designed for. I mean, it works as long. I mean, it does exactly what Zero says it does, as long as the input voltage remains stable. If the input voltage goes up or goes down, your amperage goes up and goes down relative to the input voltage. I'm finding it, I guess what I'm trying to say is I'm finding it interesting that I can dial in a voltage at the cell and it don't really matter what goes on outside the cell. See, now I wish I hadn't got it warmed up. So I think the next one I want to try is I want to try a 3N5 and see if I can dial it down to whatever the bottom end is. I'll have to find out what the bottom end is of the PWM. That'd be cool, actually. I don't know what I'm looking at. All I'm saying is it's interesting. Interesting anomaly. Alright, this is Luther P40 signing off. Thank you very much for taking the time to watch my videos. Take care.